This video introduces the problems associated with statistical inference on a mean. In other words, we're going to draw a conclusion about the average of a group of data. You'll recall our previous module on sampling distributions introduced us to something called the law of large numbers, which is basically a statement that as the sample size increases, our accuracy increases, which is not too surprising. And in fact, we had some mathematical relationships describing this. If we were analyzing a proportion, the standard deviation, the uncertainty associated with that sample proportion, was root p1 minus p over n. And we've been using this to develop confidence intervals and hypothesis tests in the previous couple of modules. And we also recall from the dim, dark, distant past, looking at sampling distributions, that for a mean, the standard deviation was sigma over the square root of n. We're going to make use of this latter factoid in the coming example. And so we go out and take a random sample of 5 students and ask them how many hours of sleep in the past 24. And we get those data. As a first step toward analysis, we're going to need to know the mean and standard deviation of that sample. And so I'm going to ask you to find that sample mean and find that sample standard deviation. Let's take a minute to review some stuff from a couple modules ago. So pause the video here, work through the sample mean and standard deviation, then unpause the video to check your answers. Sample mean, that's pretty straightforward. Just add them all up. They add up to 30. We divide by 5. The average person in our sample got 6 hours of sleep. Standard deviation, we remember, is average distance from the middle, although we're finding that average in a somewhat creative way. Distance from the middle. Alfonso here, 8 versus 6, got 2 hours of sleep, more than average. 3 minus 6, Buford got 3 less than average. 2 minus 6, Clyde Arthur 4 less than average. 10, always an overachiever in the class. 10 hours of sleep minus 6, 4 above average, and 1 above averages. These are distances from the middle. We square them to keep the negatives from canceling the positives, and average those. I hope you heard the air quotes in my voice around the word average. Yeah, we add them up, but we don't divide by 5. We divide by number of data minus 1 and minus 1. Why? Because remember that our sample tends to be a bit less spread out than the population as a whole. So add them up, divide by n minus 1. The resulting quantity is called the variance. We take the square root of that to get our standard deviation. For this problem, approximately 3.39. So now the question is, for these data, what's the population mean? And the answer is, of course, we don't know. We've only surveyed 5 students. We haven't surveyed everybody on campus. But we did a random sample. Our sample should be representative of the population as a whole. And so we can make a reasonable guess as to what the overall average is. And that overall population mean is probably somewhere around our sample average of 6. We don't know exactly what it is, but it's 6-ish. In other words, we want a 95% confidence interval for that population mean. And we know confidence intervals are of the form best guess plus or minus some number of standard deviations. Here our best guess is 6 hours of sleep. The standard deviation, since this number is a mean, we want the standard deviation associated with the mean, which is sigma over the square root of n. So what's sigma in this problem? This is a trick question. The answer is, we don't know. Dr. Rask, we just computed a standard deviation. It was 3.39. Yes, but that was the standard deviation of our sample. What we need to know is the standard deviation of everybody on campus. We don't know that number. So what do? Panic. The problem is, while we want a population standard deviation, we don't have a population's worth of data. We're introducing some additional uncertainty into our problem that's going to affect the uncertainty of our answer. How do we go about doing so? That's the subject of the next video.